Here is another quadratic-like equation. Notice when you square x to the 1/5, you get x to the 2/5. So we're going to put y equal to x to the 1/5. Alright, and write this as y squared plus y minus 2 equals 0. And here we have factorization y plus 2, y minus 1. Okay, so we get the two solutions, y is equal to minus 2 and y is equal to 1. Now to get the x solutions, let's replace y with x to the 1/5. X to the 1/5 is equal to minus 2. X to the 1/5 is equal to 1. And now we're going to raise both sides to the exponent 5. So here we get x is equal to minus 32. And here we have x is equal to 1. Since we didn't raise both sides to an even exponent, they're both valid solutions. We raised both sides to the odd exponent of 5. You can check this in any case, just to be on the safe side, but these are valid solutions. Number 20, we have another quadratic-like equation. We're going to put y equal to 3x plus 1. And we have y squared plus 2y minus 15 equals 0. And let's factor this. So this factors into y plus 5, y minus 3. So we have two y solutions, y equal minus 5, y equal 3. And now we need the x solutions. So let's replace y with 3x plus 1. Subtract 1, and we have x is equal to negative 2, and subtract 1, and we have x is equal to 2/3. Alright, again, quadratic-like. Okay, we're going to put y equals square root, 2 times square root t plus 1, so let's see, we have y squared minus 2y minus 3 equals 0. Factor, we have y minus 3y plus 1. And the y solutions. Alright, now let's substitute back. And we have 2 square root t plus 1 is equal to 3. 2 square root t plus 1 is equal to minus 1. Alright, we're going to solve these equations. So subtract 1 from both sides. Let's divide both sides by 2. Square both sides. Now notice we squared both sides, so we must check. Alright, here subtract 1. So it's the square root t there. Divide by 2, square both sides, and we still get t equal 1. But again, we must check. So let's do our check right here. Let's say we do it right up here. So we're going to check that one solution, t equal 1. Okay, substitute in, and we have 2 plus 1 squared minus 2 times 2 plus 1 minus 3 equals 0. Alright, so this is 9 minus, this is 2 times 3, minus 6 minus 3, and yes, that is equal to 0. Alright, so here's our valid solution, t equal 1. One valid solution. Here we have an inequality. Let's simplify first. Multiply by minus 2 to open these parentheses. 3 minus 10 plus 6x is less than 2x minus 4. So we have minus 7 plus 6x less than 2x minus 4. Let's subtract 2x from both sides. Let's add 7 to both sides and divide by 4. Here we have two inequalities separated by an or. We'll solve separately, each one. First, let's eliminate these fractions on the left. Let's multiply both sides by 12, since both 3 and 4 will divide into 12. So let me write that over here. We're going to do 12 over 1 times 2x plus 1 over 3 less than or equal to. And here we have x over 4 plus 1, and again we're multiplying by 12 over 1. On this side we have divide 3 into 12, and we have 4, multiply through that numerator, and we get 8x plus 4 less than or equal to, and here multiply through by 12, and we have x over 4 times 12 over 1 plus 12. So here we get 8x plus 4 less than or equal to 3x plus 12. And now simplify, subtract 3x from both sides, so we'll get a 5x. Subtract 4 from both sides, and here we'll get 8. And we get x less than or equal to 8 over 5. All right, that's the first. Let's see, maybe we can do the second one right here. Okay, this one. 3 minus x over 2 greater than x over 3 minus 1, and we'll clear out the denominators, multiplying both sides by 6, since 2 and 3 divide into 6. All right, so here we divide 2 into 6, we get 3, multiply through, and we have 9 minus 3x. Multiply through by 6. I'm just going to do this without writing everything out. 3 into 6 is 2, so here we'll get a 2x minus 6. All right, now I'm going to subtract 2x from both sides, so we'll get minus 5x on the left, and subtract 9 from both sides, so on the right we get a minus 15. And now divide both sides by negative 5. Since we're dividing by a negative, we have to switch direction here. And I get x less than 3. Now let's look at these two inequalities. So we have x less than or equal to 8 over 5, or x, these are connected with an or x less than 3. If we look at these on a number line, let's say we put 3 on the number line, that would be, let's say, here. And x over 5 is to the left, it's less than 3. Sorry, 8 over 5. All right, so here's numbers less than or equal to 8 over 5, and then less than or equal to 3, so that it just swallows it up. So we conclude that we can just simply say x less than 3. So that'll be the answer, x less than 3. You could say this or this, but this is really the better way of saying it. It's better just to say x less than 3. It's redundant to say that x is less than or equal to 8 over 5 as well. So we'll just say x less than 3. We'll start number 24 by multiplying all three sides by 3 to get rid of the denominator in the middle. So on the left we have minus 15 less than 1 minus 2x less than 12. Subtract 1 from 3 sides, minus 2x in the middle. Here we have 11, and here we have minus 16. And then we divide by minus 2, which will flip these around, and we get x, and here we have negative 11 over 2, and here we have 8. Okay, let's write this forwards. and have it read the same way. So we have 8 greater than minus 11 over 2 and less than 8. And number 25, start by isolating the term with the absolute value. And now we're ready to open up the absolute value, and we're going to have two expressions, two equations. 3 times 5 minus 2x is equal to 8, and 3 times 5 minus 2x is equal to negative 8. And we'll just solve both of these. So here we have 15 minus 6x equal 8. 15 minus 6x is equal to minus 8. Actually, let me just work on one at a time. Let's work on this one. So subtract 15 from both sides, and we have minus 6x is equal to negative 7. And so we have x is equal to 7 over 6. And subtract 15 from both sides, and we have minus 6x is equal to negative 23. And divide by minus 6, x is equal to 23 over 6. All right, let's look at number 26. We're going to open up absolute values and get two equations. 2x minus 1 is equal to 5x plus 7, that's 1. And the other one is 2x minus 1 is equal to the negative of 5x plus 7. Solve both. All right, let's subtract 5x, 2x from both sides, so here we get a 3x. And let's subtract 7 from both sides, and we get a negative 8, so x is equal to minus 8 thirds. And on this side, open parentheses, minus 5x minus 7. Add 5x to both sides, 7x. Add 1 to both sides, and we have x is equal to minus 6 over 7. Number 27 is the case that we have to check. Let me just show you what that case is. If we have some expression squared, some expression in absolute value equal to another expression, not an absolute value. So this is the case where we have to check. We solve the same way we did the previous one. We have two equations, 3x minus 5 equal x plus 2, and 3x minus 5 equal to the negative of x plus 2. All right, subtract x, and we have 2x. Add 5 to both sides, so we have x is equal to 7 over 2. All right, that's one equation. Here, start by opening up those parentheses. Let's add x to both sides. Let's add 5 to both sides. And we have x is equal to 3/4. So now, like I said, we must check. So first let's check x equals 7 over 2. So here we have the absolute value of 3 times 7 over 2 minus 5. We want to know, is that equal to 7 over 2 plus 2? Okay, let's pull this up. All right, here we have 21 over 2 minus, let's change this to 10 over 2. And we want to know, is that equal to 7 over 2? And let's change this to 4 over 2. All right, so we have, on the right, we have 11 over 2. And we want to see, do we get 11 over 2 over here? Yes. On the left, we have the absolute value of 11 over 2. Oops. The absolute value of 11 over 2, which is equal to 11 over 2. So 7 over 2, that's a valid solution. All right, let's check x is equal to 3/4. So we're going to substitute into, let's see, let me find the equation. Substitute into this equation. All right, so we have 3 times 3/4 minus 5, an absolute value, and we want to know, is that equal to 3/4 plus 2? All right, so in absolute value we have 9/4 minus 5, we'll change that to 20/4. Is that equal to 3/4 plus, we'll change this 2 to 8/4. So inside absolute value we have minus 11 over 4 in absolute value. Is that equal to, on the right, we have 11 over 4. Yes, they are equal. So this is another valid solution. So we have two, 7/2 and 3/4 are both valid solutions. Number 28, let's isolate the absolute value. Start by writing absolute value of 2x plus 1 less than 13. All right, now we open up a less than, absolute value less than the number, we open it up as a double inequality. Put the 2x plus 1 in the middle, 13 on the right, minus 13 on the left. Okay, let's subtract 1. Here we have 12 on the right, minus 14 on the left, and divide by 2. Okay, so we open these up as a absolute value less than the number becomes a double inequality. And here we have absolute value greater than the number, that becomes an OR. So here we have x plus 5 greater than 15, or x plus 5 less than minus 15. So let's solve this one. We have x greater than 10, or subtract 5 from both sides, x less than minus 20. Number 30 is of the same form as the previous example. We have absolute value greater than the number. Greater than opens as an OR. So we're going to do x over 2 minus 1/3 greater than 2/3, or x over 2 minus 1/3 less than minus 2/3. All right, let's multiply by 6 here to get rid of those fractions. All right, here we get in the first multiplication we have 3x, since the 2 divides into 6. On the next multiplication, 3 into 6 is 2. And here we have 3 into 6 is 2. 2 times 2 is 4. Okay, let's continue solving. So we have 3x greater than 6, x greater than 2. All right, on this side, again, multiply by 6. Or on this side, we're going to start with 3x minus 6 over 3 is 2, less than 3 goes into 6 2 times, so here we have a negative 4. Add 2 to both sides, and divide by 3. And these are connected by an OR. All right, number 31, we're simplifying this expression involving I. Let's remember that I to the 4th is equal to 1. And in fact, I to any exponent that's divisible by 4 is equal to 1. So we're going to rewrite I to the 27th as I to an exponent divisible by 4 that's less than 27. So let's keep going down until we hit a number divisible by 4. Okay, 26 is not divisible by 4, neither is 25, but 24 is. So we have I to the 24th times I cubed. So that's how we rewrite I to the 27th. Now this is 1. So we're just down to I cubed. Let's also remember that it's important to remember that I squared is negative 1. So I cubed is I times I squared. And this is negative 1, so here we have negative I. All right, now we're going to multiply these complex numbers. Again, it's important to remember here that I squared is negative 1. That's all we have to remember for multiplication. All right, so let's multiply these. So we have 3 times 2 is 6, and then I squared is negative 1. All right, so that's first times first. Then we have the outer, that's minus 15i, inner plus 2i, and then minus 5 at the end. So we have negative 6. Here we have negative, add these, negative 13i minus 5, and let's just combine the minus 6 minus 5 is minus 11 minus 13i. And the way we divide complex numbers is we multiply top and bottom by the conjugate of the denominator. So that would be 5 plus I, top and bottom. Alright, so let's multiply that. In the denominator we have a squared plus b squared, that is 5 squared, plus the coefficient here is 1. 5 squared plus 1 squared, so that's 25 plus 1 in the denominator. In the numerator we do this a FOIL multiplication, and we have 15, 3 times 5. For the middle term we have 10i plus 3i, that's plus 13i. And for the last we have 2i times I, that's 2 times I squared. 2 times negative 1, so that would be a minus 2. So we have this 26 in the denominator. 15 minus 2, that's 13, plus 13i. Notice everything's divisible by 13, so we might as well do that. Divide top and bottom by 13. In the denominator we get 2. In the numerator we have 1 plus I. So we have 1 plus I over 2. Or we could write this as 1/2 plus 1/2 I. In number 34, we have a rational inequality. Let's factor the numerator. So we'll just pull out an x. We have x minus 5 in the numerator. In the denominator, x minus 2 less than or equal to 0. We're going to put the zeros, or the roots, of the numerator and denominator on the number line. So we have 0 for this factor. For this factor we have 5, and for this one we have 2. So we put them in order. Now the zeros of the numerator get closed circles, because that's where this expression is equal to 0, and the 0 of the denominator, 2, gets an open circle. Now we want to know when is this less than or equal to 0. So that is, when is it negative or 0. Alright, let's just put some arrows here. This is where it's 0. So we do want to include these points. Alright, now we're ready for our plus-minus analysis. So just start substituting in something in this interval, let's say 6, and everything is positive. So we have positive here. And let's say we substitute in something between 2 and 5 here, and we have positive, negative, positive, so this will be negative. And let's say we substitute in a 1, and we have positive, negative, negative, so this is positive. If we substitute in the minus 1, we have negative, 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 3 negatives, so this is negative here. Now we want to know negative or 0, so let me just shade in the negative intervals. So for this piece, we're going to include the closed circle. We have x less than or equal to 0. And this piece, we have x, don't include the 2, because that's not where it's 0, but include the 5. All right, let's look at number 35. First, let's make sure that we set this, that we have 0 on the right-hand side. So before we factor, x to the 4th minus 25, x squared greater than or equal to 0. Okay, now we're ready to factor. Pull out an x squared. And let's factor that x squared minus 25. So we get, from here we have x equals 0, and from here we have x equal minus 5, and from here we have x equal 5. Let's put those on the number line. All right, starting with minus 5, 0, and 5. And they all get closed circles. Nothing's coming from a denominator. All right, now let's do our plus minus analysis. If we substitute in 6, let's say we do in here, let's look at this one, substitute in a 6, and we have everything positive. Here let's substitute in the 1, and we have positive, positive, negative. If we substitute in, let's say, minus 1, we have positive, positive, negative again. And let's say we substitute in minus 6, and here we have positive, negative, negative, which would be positive. Now let's say what we want. We want to know, when is this greater than or equal to 0? So that's positive or 0. So we do want to include the zeros. Okay, so we definitely want to include these, positive or 0. All right, positive, I'll shade that in, shade that in. So we have x less than or equal to minus 5, we're including that, and x greater than 5. So these are the positives and include this point, and these are positive and include this point. Okay, and of course there's one other point we have to include. We didn't include this. This does not include this 0. Notice I marked this with a yes. Okay, so we have one more point to include, x equals 0. Let's not forget about that. All right, so here's the final solution.